make sure this is recording. Hope everyone's doing well. We can do some Arnold. I did install it. It's going to be watermarked, but we'll be... So the whole idea with OSL, or Open Shading Language, is you write code once, and you can use it with any renderer that supports OSL, which most like modern renders are supporting now. RenderMan supports it. Arnold supports it. Redshift supports it. So it's universal in that sense. And it's really nice because you can use noises, and you can know that they'll evaluate the same. The Arnold docs do a good job breaking it down. There's also a GitHub repository that the Redshift people are maintaining. And then if you follow these links, like this is the main OSL GitHub repository. I think that other people will share shaders and stuff like that in different places. So you can grab code that's already written if you're not super experienced with typing it yourself. So even if you're not a programmer, it still might be useful to you. But we'll just be looking at simple code today and just how to set it up, how to use it, and that kind of stuff. So yeah, we'll just get started here with a Houdini session. Let's put this over here. And let me take a look here. So yeah, I think a really good example of some of the things you can do, Lee Griggs, the legend, the boss, he has a really good collection of just like example images that he's made. So I think all of these he's made leveraging kind of the capabilities of OSL. So like even these interesting directional scratches, anisotropy, circular patterns. How do I subscribe with Prime? I'm honored that you would like to do it. So yeah, if you click the subscribe button on Twitch, I believe that there is a option. Naranjos just showed you how. Thank you for the Prime, Naranjos. But yeah, if you click the subscribe button, the bell or the heart, or ring the bell or whatever it is, there should be an option in like the second tab or whatever to link your Twitch account to your Amazon Prime account, and then you can subscribe for free. So yeah, Lee has a fantastic repository there, and then I think it's Saul. And his Patreon, if you want to support him, he's super talented. And then he has his... Ooh, Daniel, you figured it out. Thank you for the Twitch Prime. Let's go! So, yeah, this is his repository of OSL shaders. And then the way that he has it organized, each of these, there's like a JPEG file that goes with it as a little example. And then the code is the .osl file. So you can use these OSL files actually externally, or you can use them like a snippet inside of Houdini. We could take... This one's a little bit... I want to just start with a simple one. This hexagon one looks pretty simple. So you can just highlight the code like that. Bam. Saul's Patreon. Let me get it in a second. I'm just going to clear my clipboard. So we'll make a Redshift or a RS material. And Whoops. Material builder. And then you should, if you type OSL, you can find the RS OSL node. So this file, this would be if you downloaded the .osl file. If you switch it to text, you get a nice like snippet kind of. If you're familiar with wrangles in Houdini, similar concept. The only difference is it doesn't compile automatically. You have to click this button, and then this builds the parameter interface for you and connects all the outputs and everything like that. Okay. Boom. So yeah, if you're super interested in Redshift, I highly recommend Saul's Patreon. The Art of Saul. That's his proper URL. Dr. Drek. How's it going? So you get this node, and this works kind of like a texture generator, or even like a Maxon noise. It's just generating, synthesizing or generating colors that you can connect. You can use it for displacements, you can use it for like diffuse color, you can do all sorts of stuff. But just for this case, very simple, we'll just connect it directly to the surface. So that will, or that should kind of override the shading and just make it a constant shader. And you can get some test geometry. Do you guys have any test geometry preferences? Let's just make one of these geometries. Maybe the Platonic, Euclidean, very nice geometries. So let's take a look here. Some of these are nice, but sometimes it's hard to get them to stand up on their edges. Pig head. The pig head's good. We'll do this. Just turn off the shader, because this is for the shader is only for like mantra or karma, or the Houdini shaders. And then if you want to put it above the ground plane, quickest way to do that is just this match size. And then justify Y, you set that to minimum, then it automatically will place it to be resting on the ground plane. Maybe we'll add some subdivision to it just to fix like some of that oddness. Sometimes with adding normals, if you do by face area, it doesn't always help, but sometimes it gives you a little bit better, can fix some of those errors or whatever. All right. So we have our test geometry, and we'll just make a grid for a ground plane. I'm gonna quickly make a Redshift light, just a grid light. And then we can make our camera. Look at that. Ready to go. Usually I do this sensor size or aperture at 36. It's like a standard full frame SLR if you or DSLR if you shoot with that. So like 50mm lens makes more sense now. It's like these are the millimeters are actually like real lens lengths if you're familiar with like shooting in real life. All right. You ended up using Mantra for your emissive. Oh yeah, Mantra is pretty good with instancing lights. With Redshift, sometimes you have to hack into it a little bit. So I think we're good with that. And then we can just make a new pane, Redshift render view, and hit render. So we don't have any shaders or anything applied yet. The other thing I'm going to do right now is just disable my ASUS color management. So they've switched the way that you manage that. If you want to disable it and just work with like sRGB, you can go to System tab of the Redshift settings. And then if you just move this to Scene Linear sRGB, and if you click the gear over here, just do untone mapped, then this should be similar to like just how Redshift was working out of the box before. Okay. So let's assign our material. Bam. You might need to refresh, and then it looks like it's doing something. So if we look at our parameters here, it should be generating some hexagons. I think maybe my is it this vector here? You should be able to adjust the frequency of them. Unless this is actually looking for the UV input. Yeah, I think that's looking for the UV input. Where is this vector? So if things are looking for the UV input, I think you could directly reference the coordinates yourself in the shader. This is vector. Let me see if this works. Oof. Vector. So this is multiplying it by, what is this, SY? I don't know. I'm gonna switch to a different one. This one is Damn Panders. How's it going? All right, let's get back to I lose my window as well. Let's just start from scratch. So we can do delete, and I'm just going to do a fresh OSL shader. We'll do text. We will get a little organized. Let's see what we get. Okay. So we'll go back into the shader. And we'll just call this shader will be my test. And then you just do open parenthesis like that. And then you could set up what this will be. So we're going to output a color and You could call it C, and you could set it equal to whatever you want. Like, we'll just do 1 by default. So let's see. Ooh, we already got a syntax error. Okay, so I think we need the rest of the actual like body of the shader. Do the Egyptian style brackets, the curly brackets, and this is where we can set C. So set it to a vector. Let's see if this works. Do maybe a color to see what happens. All right, look at this. Mitchell's. So the main benefit of OSL shaders is that you can use code, and then they are cross-platform. So traditionally with Redshift, if you wanted to do more advanced mathematical operations, and like these League Rigs links that I shared earlier, if you're newer in the chat, I'll share the link again. But these are really good demonstrations of some of the capabilities. So like if a certain feature isn't supported in your render, you don't need to worry about it, and you can just use the same code and keep reusing it. So you can do like directional scratches, things like that are really cool, and you don't need to worry about if your render supports it or not, because this OSL is open source, or it's kind of universal. So like Redshift with math, if you wanted to do some advanced operation, you might find yourself using a lot of these, like absolute value, sine operations. And then if I wanted to use this, do the same technique in Arnold, I would need to find the equivalent mathematical operations in Arnold. But with this code, it's the same syntax, so you don't need to rewrite your shader. That's the main advantage, I would say. Texture bombing. Yeah, I did some texture bombing, not with OSL, but with the mantra technique. I think there's someone that wrote a really good article about it a while back. So yeah, this article is really cool. They made a really good breakdown and OTL system and stuff like that for doing texture baking or texture bombing. But yeah, you can do this technique. I think on the League Rigs page, he was kind of texture bombing some graffiti. Okay, so it's working. We have red, we have green, and we have no blue. So that's giving us yellow. You can check here if you want to with the blue is turned off, red is turned on, so-and-so. So it's working. And that's really cool. So let's get a little bit more advanced now. And let's see if we can get UVs working. So I think you can just reference them like this, compile. Now you can see we get this like automatic remapper. So if you have another attribute, like sometimes you have multiple layers of UVs, you could reference them that way, or like remap them that way. Ooh. So we have UVs, which is really nice. Let me get back to that. Trying to find that Arnold link again. So on that Arnold page that I was going through earlier, there was a link to the spec for OSL. So I think if we go here, the bottom, we can find it with shaders, operators. All right, I think I'm still a little bit lost. You could find it, I think, if you just do like OSL language spec. So it's a PDF. You can just put it in the downloads like that, and you could find it here. So the reason I'm bringing this up is like if you really wanted to, this is how I'm figuring out some of these variables, like what's built in. So if we go look for it, data types, language syntax. Here it is. So these are like the global variables, or the variable mappings. So you can see we have U and V. These are the texture coordinates. We have like P, which is the position. I think it's in shading context or like shading space. So you could try doing P instead of UV. And then we should see the actual position. So if you wanted to work like noises, sometimes you have the option. If we look at the max on noise, you have the option here for the input source, object space, or working off the UV coordinates. That's the same idea here with what coordinate space we're using to visualize. We're going to be working with the UVs though. So we're going to be ending up today with this fun spiral hypnotizing animation. So we want to stick with UVs, and we can plow ahead. Ooh. All right. So let me restore this Houdini scene file, and then we can do it. I'll share the scene with you guys if you wanted to follow along. So I think the OSL stuff is still pretty new. You might want to be a little bit careful with like crashes or stuff like that. But for me, it's part of like the long-term goal. Maybe in a couple years, they'll have it worked out well enough between all the renders and USD and everything that you can just look dev your assets in one place, and then you don't have to worry about ever messing around with that stuff again, which will be super nice. This is like right now you have to keep look deving or remapping like aspects of the shader for every render engine you want to use. So let's put this, just make a new stream directory, the 9th. This will be intro to OSL. And I don't think I made any mistakes in the code. I think we just got unlucky with the crash. So let's just make sure it works. All right, we're good. So yeah, if you want to follow along, you could pick up this scene file. You could grab it from right there. And that's really nice. So if we look back at our spec, you can see we also have time. And I think that this is a little bit, so it's not the time over the duration of the shutter, it's also like your global scene time, which is pretty useful. So if I type in time, compile and build again, and then let's go like 1 second in, the blue channel should now be lit up. So as time increases, that blue channel will get brighter and brighter because we've remapped or inserted time into it. So that's another thing that we'll be using today. We'll just turn off the grid. Let's go into the main geo, and then we'll switch to a torus. Turn it on. And then you can see right now our torus, it doesn't start or it doesn't have UV attributes at all. If you just do UV project, the UV project node itself is really nice. So it has a toroidal projection type, which will match a torus. You can do initialize, click that script, and then if we look at the UV space, it's nicely laid out. You would check it if you want with the quick shade. We can see it. So if we don't have those, it just does this like orthographic, where we got top-down projection, we get some ugly artifacts. So now we have a nicely, perfectly UV'd torus. And if we go back to our shader, you can see we visualize it and everything like that. So we'll move the camera around to go inside of it. And then we'll switch to a wide angle lens, maybe like 12 millimeters. And that's how we can start to get that this kind of perspective, or this, let's get back. All right. So this kind of perspective is just from the zoomed in torus, which is pretty cool. And yeah, Panders, you could go ahead and ask a question. If it's like too much of a side tangent or something like that, I might not be able to get to it, but feel free. So we do sine of u. Maybe need to compile. All right, so before we get into the torus, let's just start with a grid. It's going to be a little bit simpler. Yeah, I saw this question in the Discord. I'll try to answer it later today when I have some free time, but I think it's going to be too much of a side tangent for me to talk about right now. Yeah, I think he put the same question, or they put the same question in the Discord. But yeah, if you add a scene file or anything like that, it can help people in the Discord give you a better answer as well. So let's just do a grid, make it a unit size, and then we can do a UV project. And just make a duplicate of this and initialize it. So I'm just going to start on a grid, so it's going to be simpler for people to, like, you can't see the entire torus, so it would already be a little bit like hypnotizing or confusing to start with that. So we have, let me make sure our coordinates, we have a projection problem. So we just need to switch to orthographic. Okay. So we're doing a sine of the u function. So if we just start and we look at only the shader u coordinate of uv, you can see it looks pretty similar. So it's just starting at 0 at the left side of the grid and then going to 1 at the right side of the grid. And if we do a sine, it looked pretty similar. But I think this side, you can tell it just doesn't get as bright at the right side of the grid. So if you increase the frequency of your sine function, you could multiply it by 8, compile again, and re-render. You start to see we get some ripples. You do 98, really big number, and you'll start to see the pattern, hopefully. So we start to get this typical sine wave up and down. So the output of the sine wave will go from -1 to 1. So you need to be a little bit careful with negative numbers. And then the one thing I like to do with this frequency here is that this sine wave input, it works in radians. So for one full rotation, you can actually type in m_pi, and then that should automatically, like, that would be 1/2 of a cycle. So it should go from black on one side to black on the other, and fully bright in the middle. So this is a good way to make sure that you're, now you know with your frequencies, if you want this, if you do 2π, then that would be one full cycle. So just to make sure you know exactly like what's going on, it's a good idea sometimes to work this way. So half of the grid, it goes positive, 0 to 1 to 0. And then the other half of the grid, it's going negative, from 0 to -1, back to 0. So let's do maybe another multiplier by 8. And then we should get 8 full repetitions. Yeah, if you use the Discord, you should, saw you in there, but if you need a link or anything like that, you can do !Discord. Yeah, and for uploading files or sharing screenshots or stuff like that, that's the best way for bigger, more technical questions or stuff like that. Okay, so we have the sine, and we're doing our stripe kind of stuff like that. If you want to check as well, we also have not only the u coordinate, but we have the v coordinate. So I'm just working like this to overwrite my c variable, or the output. And we should see, instead of horizontal, vertically, we have a ramp, or the shader coordinate. Do you do the same thing here? If we do sine or cosine? Oops. Cos. So we can do the same idea here. The only difference between sine and cosine is where they start. So instead of starting at fully black, like, it's offset like a half cycle, if that makes sense. So again, if we wanted to do this, we'd multiply it by m_pi, compile, check it again. And if you look in the spec, I don't see it. If you search maybe for OSL, you can see that other people were using this pi. It's a built-in math function. So instead of typing like 3.141 blah blah blah, you just use m_pi. All right, so that's working. If you want to comment It's the same way as Vex snippets and everything. You just do the 2 slashes. So doing this, we should get back to the horizontal. And then what we can do if we want to start to twist this stuff here, we can offset or add V to our sine. So what that should do is start to warp or like skew the result from bottom to top. It might be, you can see it just did it a little bit. This is something we probably want to multiply by pi again, and then could do times 8. So now we get this diagonal effect, which is pretty nice. So we're using U and we're using V to get texture coordinates from the geometry, from the grid that we're shading. And what did I do here? I think we're okay. So we're using U and V. Oh, I see what I did. And then we're using pi from the mathematic library, or the built-in mathematical constants. And then the last thing we can use that's pretty interesting is time. So compile and build again and take a look. So once we incorporate time, you should see if we move to different frames, we get this offset, which is really cool. So this lets you animate or shift your function or your pattern over time. So basically the hills and valleys just will roll from left to right. And really cool with OSL is you don't need to worry about like the different contexts too much. So if we just go to a standard material for our shading, we can use this for displacement. So we can plug this directly into there, hook that up. Maybe we'll start with a little bit smaller. Sometimes the default displacements can get out of hand. And we'll just turn on our tessellation and displacement. All right, so it still might be too high. Just make sure that we need to compile that. Should work. Might be my light is in the back side. We'll just add it. You can move the light around. Get back into the camera. It might be might just be not strong enough now. So we can use this pattern basically to do displacements, which is really cool. So if you're thinking about like things that have this pattern, maybe threads or ropes or strings or stuff like that, can be really nice. Pretty neat. Yeah, I mean it's simple, but it's definitely a building block or useful to know about for sure. So let's just go circle real quick. We'll put it on the ZX plane. We'll go to a polygon and we'll go to an open arc. And we'll just do a point jitter. So we'll randomize the points. We can do resample. Yeah, so we'll be going into Arnold real quickly at the end. But yeah, the idea with OSL is that it should be universal, like the code and everything. It should work without even like modifying the syntax. So even if you were using 3ds Max and VRay, you could follow along with OSL there. So that's the goal. I don't know if there still might be some issues with OSL, but that's the idea. So take a look. I'm just trying to get an interesting result. And then if we do sweep here, we can change our surface shape to a round tube. And this can give you UVs out of the box or by default. If you want to check them, you can use the UV quick shade. You see we get the automatic UVs. Let's try to find an interesting composition. Ooh. All right. Another thing, sometimes if you get these sharp edges like that, you just move your max stretch to 1. I can try to solve that a little bit. Maybe just go to subdivision curves. Did I pulled the sneaky one on you, player 2? So let's see what we get with this. Ooh, look at that. So we'll go to our Redshift. Yeah, snuck a live stream in. A Friday morning special. What is VCT? So I'm just turning on diffuse bounces, and we can turn on our ground plane again, I guess, if we want to make this lighting a little bit better. And you can see here maybe our displacement's a little too extreme. I never played Valorant. The only games I'm playing is Counter-Strike or Halo. There's a bit of a boomer game lineup there. So dial back our displacements. Try it again. That's pretty cool. Starting to look more like a fabric or something like that. The best games ever. I guess it seems like everyone's playing Apex or Overwatch or Valorant. Or like Rainbow Six was pretty popular. Okay, so I'll reduce the scale a little bit more, and then in our OSL code, if we want this rope to twist, can even build this out a little bit with like variables. So we could make a float that's called twist. We could set it to 12. And then if I plug that into the V scale, we should see this twisting at a higher rate. So that's pretty cool. You can, maybe we want to go all the way up to like 42. CS 1.6, the boomer background. So now we get a ton of twists. So if you're making, I don't know, like an electrical wire or something like that, maybe it makes more sense. We also have another one that we could call this like, this is going to be the number, how many bulges we have. You'd call it like maybe just overall frequency. And then by default here, it's like 2 times 8 or 16. I'm just going to override the 8 part of it. And if we wanted to go maybe just like 2, we have a lower one. You'd see how I'm starting to build this out. So we should have less ripples now. It's hard to see because we've twisted it so much, but if we go back to our simple grid, we should see the difference would be more clear. So basically we don't want a lot of twists, but we want a ton of ripples. Should give us something closer to like a corduroy pants or something like that. So you see we have a little sleeve or something. If you see these problems here with Redshift, this is like the softness or spring. You could do that for sure. Like even slime or something undulating along this could be cool. I'm just going to turn up my tessellation settings. So that should fix these artifacts. Sometimes this it's like the screen space adaptivity, or it might be switching to the bump mapping that's causing those issues. So it's a little bit better there. But yeah, if you're making a corduroy, so yeah, and then even working at like a higher resolution than textures is a really cool aspect of this as well. So if you were making like a texture map for this, we can do a really low amplitude or strength displacement, and then we could go with our frequency up to 242. So it's almost like a micro displacement. Eventually, I don't know if this is gonna nail it, but I need to do another compile. This is one annoying thing if you're working quickly is you need to keep compiling that. We should see it. So if you're wanted to make like a impression of a fuzzy, I might have gone too high with it. Fuzzy surface or something like that, you can quickly add a ton of little peaks and valleys or interesting portion of the surface that way. So I'm just going to get back to something closer to a rope. So we'll do a frequency of 16 and a twist of 8. And take a look. How do you dynamically create parameters for the frequency and twist? I believe if you put them at the top, then they'll know about it. The shader will know about it. There's some good examples for sure. So yeah, I think if we put these at the top, then they'll know about it. So that looks okay. Let's try this. Control X to cut, Control V to paste. Oof. So let me take a look at a shader for reference real quick. So I'm trying to find that GitHub page that we were looking at real quick. I don't think it was this one, but he might have made a mirror of it. So might need to define it like that. Let's see. I don't know. I haven't prepared that part of it. But if you look it up online, you should see some examples for people making parameters and stuff like that. Let me take a quick look here. If we're trying to find this really simple shader. All of these are like a little complex. These are too beastly of shaders. All right. So let's take a look at just a super simple one. This color keyer. Is it simple? So I know at the top here, this is like if you're doing inputs, like if you wanted to actually feed in inputs in that side of the node. We could take a look. Okay. So I might have just been separating these out incorrectly. Just instead of semicolons like that, you just do a comma, and you could get these are pretty exponential ranges to it. I think you could, if you use brackets and stuff, you could change those lower and upper bounds of the shader as well. So if you make these parameters, you might be able to get away without, then you don't have to recompile and build each time. Yeah, of course. Sorry, I'm a little disorganized. We'll go maybe a little bit higher of an amplitude. We'll run the displacement. Maybe a quarter of that. And I'm also thinking if we want this to be more like a rope, we can do this absolute value function. So what this absolute value does is it, instead of like a peak and a valley, it will just only do like outwards or only displace outwards. So it should look a little bit more like a rope or something like that. We'll just go a little bit lower with these settings. This is like too much, like a corduroy or something like that. So that's kind of the idea. It might still be a little bit too much. We should get our nice rope. All right. So hopefully you get the idea now. We have our different parameters and we can get back to the torus, and we'll finish up with this thing for today. So I'll just go up here to version 2. And if you guys want the rope, there it is. And we can turn off the grid. Get back to go with our grid. Torus. Let's just start with the grid again. So you can make a new OSL, go to text. Don't really need this stuff. We'll just start again with my test. Color. So at the top, this is like you're declaring all of the, you'd see here we were doing the inputs with the parameters and then the output. I don't know if this is gonna, it's possible it doesn't like me to do it like that. Let's see. Says it's okay. Let's take a look. And then last thing I'll do is just turn off our displacements. This should let us render stuff more quickly. All right, it's working. So we have a red color, and that's all we're doing. So we're gonna want sine of u for sure. We're gonna want to scale it again by pi. That just makes sure that it's a little bit more predictable. This guy is letting me know I have an error, so I had just missed a parenthesis there. So we want to do that for sure. We probably want to multiply this by something like 8. And then we want to do our offset using the V, the horizontal skew. And I'm going to multiply that as well by pi. And then maybe just by like 2. So that's how we get there. I think we can switch to our torus, get a more interesting composition. Let's see what we get. It's kind of working. It looks pretty cool. If we want to get rid of this faceting stuff there, we could turn on tessellation. There you go. Now we get a smooth, kind of like render time subdivision. We'll subdivide these quads to give you smooth results. And we can check. We can add time, recompile. Let's take a look. So now we get a spinning motion over time. You can hypnotize yourself. And we might want to increase our frequency. Random render, how's it going? So we should get more. Did this compile? We should see some more ripples. Okay. And then we probably want to twist. Update our twist amount. All right. So now we have it. Pretty close. I think I was twisting. No, I was twisting the same way. So yeah, that's the idea with it. Can you just move the camera around a little bit? So depending on, trying to make this just a little bit more like symmetrical. But yeah, depending on your needs, you can get into all kinds of trippy stuff this way. Maybe try even longer, a wider angle lens. Whoa. See if it works. So yeah, you can get all kinds of wacky stuff that way. Okay, so we'll go up another version. If you want to get the interesting pattern, you can take a look there. Yeah, you could do a little get into the candy cane business. So if you want to add color right now with this operation here, we're basically assigning every component of the vector, so R, G, and B, to the same value. If you wanted to use like commas or stuff like that to separate it, you can do something like that. So now our sine wave is only going to affect the red channel. We might have inverted it. Okay. So I think instead of this, we want this to be red will be a constant of 1, and then the other channels will update. So now we have a kind of candy cane effect. I think this issue here is like because of negative numbers. I think you can clamp it if you use this max function. So the max function will should limit you. So if a value is lower than 0, it will use 0. That's what maximum is saying. It's kind of pick the maximum between these two arguments. That fixes our issue there. And then you can even get even more wild. So let's just divide these by 2 for the green channel. And then we should get even more psychedelic. Ooh. So we get a kind of pinwheel effect there. Let's go up there. You could try maybe looking at this. I think with this Sine, going inside the torus is the most interesting. You can find other creative angles and stuff like that that are really cool. All right. So I'll just leave that version 4. What I'm going to do now is try to enable the Arnold render, and we'll see if we can get this working there as well. So I'm using packages to manage everything. And then you can set a flag at the top of your package if you just want to easily enable or disable plugins. Sometimes if you're running like too many things at once, you can run into conflicts or issues or whatever like that. I'm not sure how to disable. I think if you look at their docs, there probably should be a verbosity setting. But yeah, if you don't like, it's kind of loud or rambunctious. If you search, I think that there's probably a flag or something to disable that. So we'll try to quickly port this over. It's not necessarily a port because we're not, there it is. So yeah, if you want to add this environment variable, you can get rid of the fuss. Okay. So we can pop that open. We do have Arnold installed now. I'm using something close to the latest version. And if we want to add the Arnold properties to this node, I think you can do add Arnold like that. So if we want to add subdivision, we can add subdivision. We're going to need to make a new Arnold material builder. And then Arnold has its own OSL node like this. Similar. We should, because we're using OSL, should be able to just copy everything and paste it in there without any code rewrite. Their buttons to manage like parameters and stuff like that are over on this side of the thing. I think that the compile stuff happens. There's no button for it. It will just happen automatically if you use hotkeys or stuff like that. The control enter to commit or to update the code when you type. So we should be good there. You get rid of that light if we want. If we want our camera to get the Arnold properties, I'm just using the shelf tool to automatically add them or whatever. And then we can do Arnold ROP. And the last thing we need to do is just assign our material. So switch us over to the Arnold material. All right. Cross your fingers. Let's go to the Arnold. Look at that. So without having to rewrite any of the code, literally just copy and pasting it, we're up and running with the same result with Arnold, which is super cool. So any render that supports OSL, you can do this. You should be able to do the same thing. We got some bonus. Can do a little bit more iterations of the subdivision. So yeah, with V-Ray will support OSL. RenderMan will support OSL. The long-term goal with like Material X, USD, and that kind of stuff. That's where hopefully things are headed. So with Material X, this is like similar to OSL, but can work with USD, and then you see that they do have. Well, let me click on that. OSL. So they will let you use OSL shaders as part of it. But in addition to just OSL, like if you're doing textures or the actual like BSDF or how stuff responds to light, hopefully more and more things will support this workflow. So we don't need to rewrite, and it's just annoying to mess around too much with things to get the same result. So we're on the right track, hopefully, with this stuff. So yeah, I'll just save this again. Could do this as Arnold, if you want to check that out. You can take a look at this link here as well. So yeah, I think that's going to be it for today. Hopefully it's interesting. Sorry, it's a little bit dry. But yeah, you hopefully get the idea. Like if you look at you get ideas for more and more things. Like you can see maybe they're layering multiple sine waves here. You could remake some of this stuff or have some interesting references. Some people have even written some more advanced ones. These look like they're texture based, but get the idea that you can start to work with sine waves to make interesting things, take stuff even further and get all kinds of interesting results. So yeah, I'd mainly just look through that Sol's Git repo for kind of inspiration or whatever, like just to look through things. This is pretty cool. All kinds of useful stuff here for sure. I think that there was the texture bombing stuff. Where was it? Ooh. This one's pretty old, right? Yeah, so RSL, this is the idea, is this was a precursor. So originally there was RSL, and then Houdini made Vex that was based off of RSL to kind of support that stuff. And then OSL is a newer iteration of that, basically. But yeah, this is 2014. This is based off of, yeah, Yayoi. She makes all kinds of cool art like that. I think that there was a texture bombing. Is it like graffiti? Random bitmaps. So this is his texture bombing setup with Redshift. I think I don't have those files, so I can't dump it in super quick. But if you're interested in taking things further with OSL and Redshift, or you could, again, because this is cross-platform and stuff like that, very easy to reuse these with other renders. Even just making like random color variations or all kinds of stuff like that can be pretty useful. So you get the idea for tons of cool effects as well. But yeah, that's it for today from me.